The continuing growth of international air traffic and the resolve of all ATS operators to improve the quality of the services provided to those involved in air transportation have resulted in deep-reaching changes in air traffic control systems worldwide. Development of exchanges between all of the major regions of the world requires that this evolution applies not only to the dense traffic regions, but also to major intercontinental channels where traffic is light. For these spaces, the technological era of the CNS-ATM concept enables innovative solutions to be applied. In this respect, the Pacific region is typical and is an ideal testing ground enabling the new technologies in communication, navigation, and surveillance to be validated full scale. A crossroads between America and Australia, the Pacific also links these continents to New Zealand and Southeast Asia. The aeronautical players in the region decided in 1991 to create a working group known as ISPAG, Informal South Pacific ATS Coordination Group, to coordinate and to consider improving trans-Pacific traffic by using satellite-sourced digital data link systems. The group also brings together ATS service providers in the region, those of communication, airlines, aircraft constructors, and representatives of international organizations. France is an active partner within this group, applying new solutions thanks to the strategic position of French Polynesia. The Tahiti Air Control Center is providing air traffic control services in a flight information region, FIR, 12 million square kilometers wide in the middle of the Pacific. In this zone, operators and air traffic players have, so far, been hampered by rigid frameworks handling flights lasting an average of 14 hours, with no display and little automation to assist them. These poor support systems obliged pilots to fly fixed ATS routes. From his cockpit, the pilot also had to send position reports and conduct all radio operations over the HF channel, which is often slow and cluttered, sometimes impossible.
Tahiti, Qantas 102, was Weebig 1303, flight level 350, Revro 1330, wind 240, diagonal 32, temperature -47.
Qantas 102, Tahiti, maintain flight level 350, report Revro.
On the ground, the Tahiti air traffic controller had to remain tuned in, manually updating his Sigma flight plan terminal for each HF position report with the actual time on the current waypoint and the next estimated fixed, sending the weather information received from the pilot, AirRep, via the AFTN. The controller, working blind and without any traffic visualization display, has to imagine the traffic. These techniques did not allow the use of flexible routes, leading companies to overload fuel and therefore less payload. In the meantime, distance separations of 100 nautical miles laterally and 15 minutes of longitude lead to further problems in attaining the optimum cruise altitude. The lack of visualization display led to work under procedural control with characteristic huge distance separation standards not found in Europe, hence the impossibility to assign optimal cruising levels to every aircraft. This was a very inefficient control system.
Communications on HF radio can be difficult at times with the signal subject to atmospheric conditions, making it sometimes not only difficult to get through, but also very difficult to understand what's being said.
The controller has to feed the computers with the data sent via HF. The FIRs around Tahiti are working on the same frequencies, which means misunderstanding, confusions about what we are hearing.
The problem before we had FANS 1 was the lack of airspace optimization and the unreliability of HF communications.
The problem with flying a fixed route was the lack of flexibility, and it seemed like getting altitudes were more difficult.
French Polynesia is a major link in the Pacific region. As of 1994, the French Air Navigation Directorate started developing the automated assistance system for oceanic control to meet the objectives of the ISPAG. In this manner, working jointly with its industrial partner Thomson CSF, the French DNA has designed a new system known as VIVO, enabling flight visualization, controller-pilot data link communication, CPDLC, and automatic dependent surveillance, ADS. Implementation of this system in successive phases enables it to be improved, gaining from the experience gathered during the preceding phases. Prior to July 1995, the ATS routes used by aircrafts over the Pacific were fixed. Since this date, implementation of the VIVO system and similar systems in the Pacific facilitate air traffic control on routes which vary according to weather conditions. These routes, whose paths change every day, are known as flex tracks. Every 12 hours, the forecast reports coming from the Bracknell Center in England are sent to the American DOT system, which generates the flex track and then send it via AFTN to ATS services and to the airlines, which create a flight plan before the flight departure. As these flex tracks change daily, the intersections with the fixed routes take place in different points on the FIR. In order to do his job, the controller needs a flex track display system. Consequently, it is thanks to the VIVO system and similar systems developed by the American, Australian, and New Zealand authorities that the use of the flex tracks is now possible. Flying these flex tracks, airlines can cut their flight times by about 13 minutes, which means a saving of over 2 tons of fuel for a Boeing 747-400, enabling extra payload to be uplifted, 1.5 tons of payload, passengers or freight. Since July 1995, VIVO has enabled the routes and flights to be displayed. Position reports are sent by the pilot on HF at each waypoint and manually entered into the system by the controller, who updates the flight data. In January 1996, a new function was added to VIVO, CPDLC. This function enables data link communications with aircrafts equipped with suitable avionics. AirInc and SETA networks are used to transport messages between the Boeing Fans 1 or Airbus Fans A and the ground. They are received and displayed by VIVO, which is interfaced with the Sigma Flight Data Processor system. Clearances and position reports are automatically processed by Sigma, which in turn updates VIVO visualization. Consequently, they no longer need to be manually entered into the flight system by the controllers. Route, speed, and vertical clearances, in fact, all air-ground messages and communication transfers use the same means. Predefined altitude fields of the pre-formatted answers helps in saving time and preventing transcription errors. The messages are then safely transmitted between controllers and pilots. They are no longer relying on HF, which remains the backup system of the data link. Special efforts have been made to obtain the best possible definition of the VIVO system human-machine interface. The aim is to minimize the actions of the controllers, giving priority to dialogue through the mouse and avoiding the saturation of the controller's display, while ensuring the automatic processing of the ground aircraft dialogue based on a combination of pre-formatted messages, about 180 ground messages and 180 aircraft messages. All these operations are carried out using ICAO phraseology. Non-routine messages are processed in free text. These data link techniques have permitted dynamic rerouting known as DARPS, Dynamic Aircraft Route Planning System, to be developed. DARPS enables one and possibly several future changes in the routes of airborne flights, providing meteorological conditions justify them. This system enables the initial route to be optimized. Thus, flight times are reduced, making for additional fuel saving.
grâce à l'aide
Thanks to
automatisée
the
du
automation in
contrôle,
air traffic
le
control,
contrôleur
the
est
controller
uniquement
has more
braqué
time
sur
to
les
spend
tâches
on essential
fondamentales.
control
Accepter
tasks,
un avion à
to
l'entrée de
accept
la
an
FIR,
inbound
donc
flight
avec
at
un
time
niveau
and level,
mineur,
provide
lui
him
assurer la
safety and
sécurité
efficiency in
tout au
his
long du vol,
FIR,
sans pratiquement
and transfer to the next
d'intervention grâce à VIVO,
ACCC,
puisque
almost without
le report de
unnecessary
position se fait
intervention thanks to
automatiquement,
VIVO
assurer bien sûr
ergonomy,
les
position
conflits,
reports, and
donc et les
air reps
résoudre,
which are
et
automatically
en sortie
processed.
de FIR, présenter l'avion dans de bonnes conditions à l'ACC suivant.
It'll make the pilot's job a lot easier. We'll be transmitting the same data that we used to transmit on HF radio with the press of a button via data link.
In fact, the one message to come from the plane and to arrive on the ground takes around 20 seconds. We have just to check that our display is updated correctly. That's all we have to do. And we've got message assurance, so we know that our message is received on board or not. So there's nothing to compare with HF.
The game for the pilot is more control over the aircraft and a lower workload. The required separation space can be condensed.
In its third phase, the VIVO system provides automatic dependent surveillance, ADS. This technology enables position reports and flight intentions to be received from the aircraft without any solicitation or manipulation by the pilots with the control system. This more accurate knowledge of the position of the aircraft and its intentions, combined with the development of specific tools in VIVO, offers conformance monitoring of the routes. So the Tahiti Center will be able to reduce separations at the requisite times in consultation with its neighbors and in compliance with ICAO recommendations. The development of VIVO highlights the requirement for all navigational players to be endowed with in-depth practice and knowledge of the new CNS ATM technologies adapted to the needs of air traffic.
The main thing is we've always tended to follow lines drawn on charts, whereas there was no reason to do that. There certainly is no reason anymore. The Pacific was an ideal place to implement this. We had a small number of like-minded civil aviation authorities and relatively low traffic densities. We're looking at the moment at the potential of using somewhere out of Asia, across China and Russia to Europe, across the Indian Ocean to South Africa. CNS ATM is expanding into other areas. We already have installations now in Singapore, in Hong Kong, developments occurring in Japan, the Philippines, Thailand, Myanmar. India is now operational in Calcutta, with very shortly in Delhi and in Bombay or Mumbai. Pakistan has gone to tender. Iran is evaluating tenders now. And there's South Africa has signed a contract. There's some very solid interest expressed by Mauritius. And now, of course, the interest that's spreading across Africa.
All this illustrates the need for stepping up cooperation and international coordination between all bodies involved in the development of this traffic. The VIVO project has benefited from the experience gained thanks to the research and development conducted in air-ground data links by the French Air Navigation Technical Service and its industrial partner, Thomson CSF. The know-how of the French Air Navigation Directory, the DNA, as ATS operator, working in the complex environment of Europe and present in the North Atlantic, has enabled France to play an active part in implementing the FANS concept with its partners in the Pacific Zone.